So at the end of the last video, I said that the other addressing modes, particularly the other indexing addressing modes, existed primarily to get rid of some instructions, to make it easier to do this section. I actually drew the arrow down here, but that's not true. We're going to still have a load A statement, because that's what we're going to do with it once we get the address we want. But it's not the case that we have to go out transferring stuff to the accumulator, doing math in the accumulator, and transferring it back, and worrying about overflows and all of that business. What we need is the other indexed addressing modes. And for that, we're going to go back to our good friend, the book. Now, this is on page 92 of said book. Remember about 3 videos ago, I said page 91 had details on the different addressing modes. This is part of that text. We're going to talk now about the IX1 and the IX2 indexed addressing modes. We are not going to talk about this IX1 plus because this IX1 plus is used only for the CBEQ instruction. That's one instruction. That's not worth talking about. An entire mode for one instruction. You can forget that that exists for this class. Now, IX1 and IX2 both rely on the same sort of idea, which is if we have in our HX register, we have some values that point to a location in memory, then it might be really cool to be able to grab something that's offset just a little bit. Kind of like that whole ZI thing that we've been talking about for a while now. If this is Z and I want this thing here, it'd be really neat to be able to index it. As it happens, IX1 is not so useful. We'll get into that in just a moment. The only difference between IX1 and IX2 is in how big that offset is. So in this case, it uses the register pair plus an unsigned 8-bit offset. And over here, if we do a difference on the text, everything else is the same, except it uses a 16-bit offset. Everything else, if you were to compare those two sentences, it's the same sentence, except for that one little spot. So let's go back to our example. Are we where we can now get rid of this section of text? Well, not quite, because we do have the ability to take this HX value, this 120, so this is 120 in HX, right? 0x0, 120. We have the ability to take this and to add an offset to it, right? We want to go to 123, so you would think, all right, the offset then should be 3. But unfortunately, if we use the load A command, and we say 3, that's my offset, and then X. What is this going to do? It's going to take load A, it's going to subsume the X into that load A command to use the right opcode for an indexed addressing mode, either IX1 or IX2. It's going to look at this offset, it's going to realize that offset is way under 255, so it can use just 1 byte, just an 8-bit offset, and then it'll use that offset to go ahead and load. So this loads Z3. But you'll notice something. This is a 3, that's a 3, and the whole point of what we've been trying to do is to use a variable offset. This, however, lives inside of the operation. It's part of the operand, it's in program memory, it's exactly what we were trying to avoid. So it does give us a nice concrete way to access little elements of the array, but it doesn't quite get us where we want to be until we realize a happy fact. If we're looking for A plus B, we could write that B plus A. And here's where things get a little bit weird. This command expects a 16 or an 8-bit offset, which we've been talking about as being that 3, and then an address in the HX register. I submit to you that if you put the address in the command and the offset in the HX register, that this does exactly what we want to do. So then instead of load A3, we've got load A ZX, but we do have to load HX register with whatever's at I first to make sure that that winds up being an I. And it's worth mentioning that this might be an 8-bit value, and so you have to worry a little bit about what happens when you load HX. So maybe you clear H and you load X. There's different ways to go about this, but the point is we put that offset, we put that 3 in the HX register. Then we're going to load A with an offset of the start of the array, and then go from there. So why did I say that IX1 was not terribly useful? Well, because Z tends to be 16-bit. Now, if you're talking about low areas of memory, you've got something in RAM that's before 0x0100, then it's possible you could have a 8-bit offset for Z, and that would be fine. It'd be faster, it'd be smaller, everything about it's better. But actually, table lookups are much more common out in program memory, and program memory starts in the E's. So it's not terribly common, at least in my own programming, to use IX1. That said, the assembler will handle it for you. You're just putting an offset here. If that offset can be described in 8 bits, it'll go ahead and do that. If that offset can't be described in 8 bits, it'll go ahead and use a 16-bit one. And this allows us, at the end of the day, to do exactly what we wanted to do. We can use any offset up to and including 0xFFFF, which is obviously way bigger than any offset we could possibly want to do, by storing the offset in the HX register, and then loading with the original variable's name there. Now you still want to do sanity checking on the value. You obviously don't want to use 0xFFFF, but we can. So technologically speaking, we're now able to access arbitrary size arrays and look up any element from them. And we can determine which one to look up at runtime, not at assembly.